2.1 linear equations in one variable. With this section, we're just solving equations. We're going to start with telling whether or not a solution or a number is a solution to the equation. So for example, 1a, we have 3x plus 7 is equal to negative 8, and we're given negative 5. So we're just going to plug that negative 5 in for x and simplify. If we get a true statement, then negative 5 is a solution. If we get a false statement, it's not a solution. So we have 3 times negative 5 plus 7 is equal to negative 8. The 3 times negative 5 is negative 15, plus 7 is equal to negative 8. Negative 15 plus 7 is negative 8. Negative 8 is equal to negative 8. This is a true statement, so we do recognize that 5 as a solution. So 5 is a solution. For B, we have 2 times x minus 1 is equal to 2x plus 3, and we're given the number 4 as a solution. So we're going to plug that in to everywhere we see that x. So we're going to have 2 times 4 minus 1 is equal to 2 times 4 plus 3. The 4 minus 1 gives us 3, so that's 2 times 3 is equal to 2 times 4 plus 3, which is 2 times 4 is 8 plus 3. The 2 times 3 is 6. 8 plus 3 is 11. 6 is not equal to 11, so 4 is not a solution. For our next problem, we have 6 minus 3x is equal to 8 minus 2x. I'm going to start by moving that 3x over by adding it to both sides. So I'm just using inverse operations to solve these. So opposite operations, that 6 and that 8 don't get worked with, so they get moved down. So we have 6 is equal to 8 plus x, because negative 2x plus 3x is x. And then I'm just going to move that 8 over by subtracting it from each side. So I get that negative 2 is equal to x. I rewrite this to where my x comes first. So x is equal to negative 2. For my next example, we have 2 times x minus 4 plus 5x is equal to 34. I'm going to start this one by distributing the 2. So I have 2x minus 8 plus 5x is equal to 34. I combine my like terms of the 2x and the 5x. That give me 7x minus 8 is equal to 34. I then add the 8 to both sides. Bring the 7x down. So 7x is equal to 42. And then I just divide by 7 on each side to get x by itself. And x is 6. Our next example, we have fractions within our equation. In order to get rid of those fractions and not work with them, you're going to multiply every single term within that equation that's not in a set of parentheses by the least common denominator of all of the fractions within the equation. So your fractions have denominators of 2, 3, and 6. So your least common denominator in this is the 6. So we're going to multiply everything by the 6. So we're going to have 6 times x over 2 plus 6 times negative 1 over 3 is equal to 6 times x over 3 plus 6 times 5 over 6. So the 2 and the 6 simplify to become 1 and 3. So it's going to be just 3 times x, which is 3x. The 3 and the 6 simplify to become 1 and 2. So 2 times negative 1 is negative 2. Again, the 3 and the 6 become 1 and 2, so 2 times x. On the other side of that equal sign is 2x. And the 6 is simplified to become 1, so 1 times 5 is 5. I'm going to move that 2x over by subtracting it from each side. I'm left with x minus 2 is equal to 5. And then I just add the 2 to both sides to get that x is equal to 7. For 5, we have x minus 0.1x is equal to 0.75x plus 4.5. I don't want to work with decimals either, so I'm going to take my smallest decimal value and take the amount of decimal places that are in that value and multiply the entire equation by 10 to that power. So our smallest decimal here is 0.75. There's 2 decimal places in that, so it's 10 to the second power that I'm multiplying the entire equation by, so that's 100. So I'm going to do 100 times x plus 100 times negative 0.1x is equal to 100 times 0.75x plus 100 times 4.5. When I multiply by a power of 10, I'm just moving the decimal on that number by so many place values, and the amount of place values I'm moving is the amount of zeros that's in my power of 10. So if we do 100 times x, that's just 100x. 100 times negative 0.1, I'm going to move it 2 decimal places, so that's negative 10x. 100 times 0.75, moving it 2 places, that's 75x. And then 100 times 4.5, I move it 2 places, that's 450. So I'm solving 100x minus 10x is equal to 75x plus 450. My 100x and my 10x are like terms, so I can combine them to get 90x is equal to 75x plus 450. I then just subtract the 75x from each side, and I'm left with 15x is equal to 450. And then we divide each side by that 15 to get that x is equal to 30. For example, 6a, we have 8 minus 3 times x minus 5 plus 7 is equal to 3 times the opposite, 3 minus x minus 5 minus 2 times x minus 1. So I'm going to distribute the negative 3. This is going to leave me with 8 minus 3x plus 15 plus 7. On the other side of that equal sign, I'm going to distribute the negative and the negative 2. So it's going to leave me with 3 minus x plus 5 minus 2x plus 22. I'm going to combine my like terms on each side of my equal sign. So the 8, the 15, and the 7 give me a negative 3x plus 30. The negative x and the negative 2x is a negative 3x. And the 3, the 5, and the 22 give me a positive 30. So both sides of my equal sign are identical to each other. If I didn't see that, I could I could add the 3x to each side. So they would cancel, and I'd just be left with 30 is equal to 30. Now this is a true statement, so my answer for this one is infinitely many solutions. For B, we have 5 minus 3 times x minus 6 is equal to 4 times x minus 9 minus 7x. So I'm going to distribute the negative 3 as well as the 4. So this is 5 minus 3x plus 18 is equal to 4x minus 36 minus 7x. The 5x and the 5 and the 18 can simplify by combining. We get negative 3x plus 23. And then the 4x minus 7x is negative 3x minus 36. Those 3x's are going to cancel each other out when you move to be on the same side. So we have 23 is equal to negative 36. Now this is a false statement, so whenever we get a false statement, we have no solution. For our next example, we have y over 2 minus y plus 4 over 5 is equal to 23 over 10. So our least common denominator here is that 10. So when we do this, we're going to multiply the entire thing by that 10, which is the least common denominator. And I'm just going to rewrite it to where I have 10 times y over 2. The negative that's in front of that next term is going to stay with the 10. And I'm going to do negative 10 times y plus 4 over 5. And then I have 10 times 23 over 10. So the 10 and the 2 can simplify to become 5 and 1. So this is just 5 times y, which is 5y. The 5 and the negative 10 become a negative 2 and a 1. So this is a negative 2 times y plus 4. And then the 10's simplify to become 1s, so that's just 23. So now we're going to distribute that negative 2 into the y plus 4. And we get 5y minus 2y minus 8 is equal to 23. I'm going to combine my like terms to give me 3y minus 8 is equal to 23. I then move that 8 over by adding it to both sides. And we get 3y is equal to 31. And then we divide by 3. And we can leave this as y is equal to 31 over 3. For our last set of examples for 8a, we have 3x plus 4 is equal to 0. So I'm going to just add that 4 to both sides. I get 3x is equal to 4. Then we divide each side by that 3. So x is equal to 4/3. And then for b, we're going to distribute the negative 2. So this is going to be 2 minus x minus 5 is equal to negative 6x plus 2 plus 6x. On the left side, the 2 and the 5 combine to give us negative x minus 3. On the right side, the 6x's cancel since they're opposites, so we're just left with the 2. I'm going to move that 3 over by adding it to both sides. So I have negative x is equal to 5. And then we just divide each side by negative 1. And x is equal to negative 5.